Hi, welcome to the exam collection. It's just half dozen exam questions that I post every week so that you're in a position to practice regularly with exam questions in preparation for your exams, and you can go in a little bit more confident. The questions themselves are all around that grade 4, grade 5, the type of questions that you might see towards the end of the paper. Today we have a collection of non-calculator questions, so no grabbing the calculator. Remember, please, that your method may be different to the one that I show as the work solution. I use the ones that I use in class with my students. You may very well use something different. So as long as you've got that evidence backing up your answer, there shouldn't be a real problem at all. Okay, so hit pause and press play when you're ready. Okay, the simplest way to approach this is to find the cost of 1 pint of milk. Then I can make a comparison. I could cross multiply and I could get 24 pints and compare that, but it would be a lot more work, and it's, yeah, the less you can do, the better. So I'm going to find the cost of 1. So looking at the smaller bottle, which holds 4 pints, we've got 4 pints for £1.18. So I want to take my £1.18 and divide it through by the 4. So 4's into 0, sorry, 4's into 1, don't go, so we've got my 0, carry the 1. I'm going past that decimal point, so it's time for the decimal point to come up. Then 4's into 11 go 2, remainder 3. 4's into 38 go 9, 4 9's are 36, so I've got remainder 2, add a 0, and 4's into 20 go 5. So that represents the cost of 1 pint. I'm going to repeat the process now with my 6 pints. 6's into 17 go 2, remainder 5. 6's into 54 go exactly 9. And that represents the 6 pints. And you can see when we compare these two that this is not a lot, but it is slightly bigger, so it's slightly more, which means this one is the better value. It says which bottle of milk is the best value for money. I haven't answered that question, so if I just leave it there, I am not getting all the marks available to me, so I must write 6 pints as part of my answer as well. So you must not fear the bus shelter. It's generally pretty straightforward once you get into it. Okay, next question. Very wordy. Read through carefully, have a go, and then press play when you're ready to see the worked solution. Okay, so there is a huge amount of information that is absolutely irrelevant in this question. Okay, so let's have a little look at it. We've got 5 schools that sent some students to a conference. One of the schools sent both boys and girls. This school sent 16 boys, and the ratio of boys it sent to the number of girls it sent was 1:2. So there's quite a bit of maths that I can do there. If you read on, it says the other 4 schools sent only girls. Each of the 5 schools sent the same number of students, and you have to work out the total number of students. And I think this reference here to the 4 other schools only sending girls can cause a little bit of confusion. It's actually irrelevant whether it was girls or boys. They send the same number of students, and that bit there is the only bit that really matters in the whole of that section. So let's go here, because this is where the maths is. So one of the schools sent boys and girls, okay, and they sent the boys and girls in the ratio of 1:2. So I've got my boys to girls, 1:2. And they make it clear that 16 boys went. So I can use this fact, I must times by 16 on both sides to help me find the number of girls, which is going to be 32. So the total number that this school sent is 16 plus 32, which is 48. The other 4 schools sent only girls. That's irrelevant. Each of the schools sent the same number of students. So my last job is to do 48 times 5. Okay, now there is different ways that you could approach that particular question. I'm going to demo with the Chinese method because that is our go-to for multiplication. And I don't have a calculator. I don't want to mess this up. So I'm just going to do a 2 by 2. I've got 48 and 5. So 40, 20, out comes a 0, out comes a 4, out comes 2. So the answer is 240. Okay, so hopefully that went well. That's the next question. Hit pause and press play when you're ready. Okay, so highest common factors. Factors multiply to make the given number. So this is where the factor bugs that we learn about in class are useful. So 2 times 6, 3, 4. And then for 20, 1, 20, 2, 10. Always do them in pairs so you don't miss any off. And then you just look for the one that's highest. And the highest number is 4. So the solution to that one is 4. Now this one, where they're starting to use slightly larger numbers, can be done in 2 different ways. On a non-calculator paper, you'd want them to reach the answer fairly quickly if you were going to list them out. Or you can use product of prime factors. I'm going to do both so that you know that these are both acceptable methods. So one of the things that you could have done was you could have taken your 32, done 2 times 16, and then 2 times 8, and then 2 times 4, and then 2 times 2. And then you'll do the same to your 48. So you've got 2 times 24, 2 times 12, 2 times 6, and then 2 times 3. This can then go into a Venn diagram where anything matching goes in the middle. So I've got a 2 matching with a 2, and you just keep going like that. It's going to be quite a few. There we go. And then there's a 3 and a 2 left over on that one. And the lowest common multiple is everything in that diagram multiplied together. So I've got 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 times another one times 3, and then work backwards. So you're doubling, because doubling is easy. So 3 times 2 is 6, 12, 24, 48, and 96 is the answer. Now, the reason why I've shown that as a kind of first method is because it's foolproof. It works. It doesn't matter how tricky the numbers get. You are going to get to the answer using that method without too much hassle. The other way of doing it is to list the actual multiples. And I don't have a problem with this at all. In this particular question, it works out really quickly. So we know it's going to be 96. So we do 32. The next one in that times table would be 64. The next one would be 96. This is 48. And then the next one is 96. So you hit that 96 so quickly that it makes much more sense to do it that way than to do it the way I just showed you. But the caveat with that is it doesn't always work like that. It's just a coincidence for this question. And I would be really careful to just solely rely on that. Imagine if you had to write 7 or 8 numbers out in a complicated times table. It's open for error massively. Okay, next question. All right, read through carefully, have a go, and then press play when you're ready to see the worked solution. Okay, so you have to be really careful with this because it's incredibly tempting to just add the 2 speeds and divide by 2. These are much more complicated than that because actually if we want an average speed for the whole journey, then we need to see the whole journey as one single distance and one single time. So it requires a lot more work than it first sort of appears to. So they've given me part of a diagram that I would draw from scratch if I needed to. but we can add more information onto that. So the first part of the story is really talking about what you can see here. And this part just tells us that he's traveling from Gcse to Drone, and then he drives from Drone to Elton. So he goes the full distance. And now we've got some information on speed. So from C to D, he's traveled 30 miles per hour. Get it up there with that diagram so it's really, really clear. And it's 40 miles per hour for this section here. We've got to work out Colin's average speed for the whole journey. Now, speed is found, and I'll just pull that up a little bit. Speed is found using distance, speed, time, triangle. For speed, we need the distance divided by the time. And that isn't separate distances added together, which is the temptation here. We want one value to represent the entire journey. So what I need to do is get some values for time, because that's what's missing. So if I take a look at this one here, I have got my distance and time. Let's just be clear about what we're doing. Time is distance divided by speed. So my distance is 20, my speed is 40. Cancel this, I get to 2/4. I can divide by 2 and I've got half. So this is half an hour, or 0.5 hours. That's how long that part of the journey takes. This part of the journey is going to be worked out exactly the same way. Distance 45 over 30. Now we can cancel this down, and it depends on kind of what you see. So you might see the 5 times table and cancel it to 9 over 6. But then you would also see that the 3 times table could be applied, and you would end up with 3 over 2. How many 2s in 3? 1, with 1 left over. So you've got 1.5 or 1.5. So the total distance traveled is 65 miles. We can't change that. So the total distance is 65. The total time that it takes is 1.5 plus another half is 2 hours. So 65 divided by 2, 2's into 6 go 3 exactly. 2's into 5 go 2 with 1 left over. That 1 is kind of hanging around at the moment. So we add that 0, add a point, and 2's into 10 go 5. So the average speed for the whole journey is 32.5 miles per hour. So really, really important, if you see a question like that, where it's broken into stages, that you bring that into one entire journey and not just adding the individual elements, if that makes sense. Okay, that's your next question. Hit pause and press play when you're ready. Okay, so the general rule when it comes to factorizing is if you've got 2 terms, then it's going to go into a single bracket, one single bracket. So we use F for factorizing for single brackets. We've got x squared minus 49. And under here, we find something that's common in both of these. So this has an x in it, but it doesn't. So that's not common. I can't choose x to go under there because there isn't an x here. This is a number 49. If it's got a shared times table, then I can bring that out, but it hasn't because there's no number. Obviously there's an invisible 1, but 1 isn't going to help change anything. So 1's no use to us. So this breaks down very, very quickly. If you just go through your process of 2 terms, 1 bracket, F for factorizing, have a go, and I can't do anything with it. It has to be doable. It's a question on your exam. So this is the exception to the rule that we teach in class, where a negative square number, and 49 is a square number, a negative square number will create a 2 bracket situation. So you drop your x, you do the square root of your number. Square root of 49 is 7, and then you've got plus 7 minus 7. Okay, plus and minus is the square root of 49, and that's showing in the brackets. So that's that one. It is grade 5. If it's something that you haven't had a lot of practice with, then it's well worth learning, because once that clicks into place, it's really straightforward. Okay, expanding. We are going to do 2y times y is 2y squared. 2 times minus 3 is minus 6y. Then we've got 7 times y is 7y. Watch out for those negatives. Always watch out. So we've got minus 21. We're going to collect that middle up, and our answer would be 2y squared. Minus 6 add 7 is going to take me to positive 1. So I'm going to write plus 1y. I don't need to show the number 1. If you have, you will not be penalized. So don't worry about that. And then you've got your minus 21 going in there on the end. All right. We have standard form. So hit pause and press play when you're ready. Okay. So whenever I do standard form, I do numbers first and then the times by 10, the powers bit second. So for this question, it's a times question. So I'm going to be doing 6 times 4, which is 24. And then we've got 10 to the 8 times 10 to the 7, which is 10 to the 15. So this is giving me 24 times 10 to the 15. But you've got to be careful, because even though that looks and feels like standard form, it is not. Standard form has only 1 digit of value and then a decimal point. And at the moment, mine's got 2 digits with value. So I need to basically divide this through by 10 to get a decimal point where I want it. One of the ways that we do in class is we just think about 24 getting smaller by 1, which means on this side, the power needs to get bigger by 1 to maintain that balance. So it's times 10 to the 16. This question, where we do numbers first and then the powers second, doesn't work because there's no power rule for addition. I could do it here because there's a power rule that says add the powers when you've got a times question. But this is an add question and there are no rules. So I've got no choice but to go into ordinary numbers. So 6 times 10 to the 8 is going to be 6 with 8 zeros. And 4 times 10 to the 7 is going to be 4 with 7 zeros. And it's really important that I get those lined up so that when I add them, I get everything where it needs to be. Now I've got to give my answer in standard form. So that's my working out. I know that my point needs to be here. So I'll just count it in to make sure I am not missing anything. So 1, 2, 3, 4, 5, 6, 7, 8. That's what I would have expected. So my answer is 6.4 times 10 to the 8. If you got that right, well done. Okay, last question. Hit pause and press play when you're ready. Okay, so Sam rolls a fair dice 150 times. Work out an estimate for the number of times the dice will land on 4. So the first thing I need to think about is the probability. What's the chance that it's going to land on a 4? Well, they're telling me it's a fair dice. There's only 1 4 on the dice. So the probability is a 6th. So the chances of me getting a 4 is 1 out of 6. So 1 4 out of every 6 rolls. What we're going to do to get the final answer is say, I want a 6th of the 150 rolls. And this is just to divide by the bottom times by the top. So 150 divided by 6. 6 is into 1, don't go, carry the 1. 6s into 15 will go 2. 6 2s are 12, so that leaves me 3 over. 6s into 30 are 5. So my estimate is 25. The 4 will come up 25 times. Okay, right, hopefully that was helpful, and I will see you next week for a new batch of questions.